Today we will be able to find all of the real zeros of a function by factoring. We're going to be factoring things that we couldn't previously factor. So take a look a little bit down in the notes where it says, what does this mean? In the function x to the third plus 2x squared minus 5x minus 6, if we tried to split that down the middle and factor by grouping, it would not work. We can't factor it. Everything that we've been doing previously for factoring doesn't work for this problem. So previously we'd say, well, crap, we're done. We can't factor it. But now we can. The fundamental theorem of algebra says that a polynomial with a degree n will have exactly n zeros. I would like you to underline the term zeros and write in there solutions, x-intercepts, and roots. They use those four terms interchangeably. Thanks a whole lot, math, that you have four words that mean the same thing. So when they're talking about zeros, they're not talking about the number 0. They're talking about the x-intercepts. They're talking about where this graph is crossing the x-axis. So if the degree is 4, if the biggest exponent is 4, x to the 4th, there would be 4 x-intercepts. If your biggest term is x to the 7th, there would be 7 x-intercepts. If it was x to the 29th, there would be 29 x-intercepts. So the fundamental theorem of algebra says whatever the degree is, whatever the largest exponent is, there are that many solutions, that many x-intercepts. As far as what kind of solutions will they be, either positive or negative, this really, really, really smart guy named Descartes, it looks like Descartes, but it's Descartes, I'm sure. Descartes figured out that if you look at the number of sign changes in a polynomial, what we mean by sign changes, take a look at this polynomial. We start out with positive x cubed, stay positive, then it changes to negative, and then it stays negative. There is one sign change in this polynomial. The number of sign changes indicates how many positive solutions there are going to be. So since there's one sign change, there's going to be one positive solution. How many solutions total are there going to be in this particular polynomial? 3. So if one of those solutions is positive, how many negative solutions are there going to be? 2. Now in Descartes' rule of signs, he does say there will be the number of positive solutions as there are sign changes or less by 2. So anytime you have 2 possible solutions, you have 2 solutions or 0 solutions. This is kind of the bummer, because there might be imaginary solutions. There are 3 solutions, but 2 of them might be imaginary. So there's definitely one real positive solution. There might be 2 solutions that are real numbers, or there might be no solutions that are negative because they're both imaginary. And we'll get into why we think about that in a minute. All possible solutions of this function, you take the factors of the constant term divided by the factors of the leading coefficient. Now our leading coefficient is 1. And what is anything divided by 1? Well, like 5 divided by 1 is 5. It's itself. So really, we don't have to deal with the fractions here like you would have to in college algebra. The constant term is the term in the polynomial that doesn't have an x. So what are the factors of 6? 1 and 6, 2 and 3. 1, 2, 3, 6. This means that positive or negative 1 might be a solution. Positive or negative 2 might be a solution. Positive or negative 3 might be a solution. And positive or negative 6 might be a solution. There are 8 possible solutions to this polynomial. we are going to use synthetic division to figure out which of those 8 is the solution. Okay? And I listed the steps down below, but I also listed the steps on the next page. So this exact example is on the next page. We are going to do this example step by step following the instructions, so then you will have a worked out problem with step-by-step instructions. Use the fundamental theorem of algebra to get the total number of solutions. This is the largest exponent. The largest exponent tells you how many solutions there are going to be. What is the largest exponent in this problem? 3. So there are going to be 3 solutions. Step 2, use Descartes' rule of signs to determine how many possible positive or negative solutions. So there is one sign change, and let's talk again about what that sign change means. This polynomial starts out with positive x to the third, positive 2x squared, negative 5x, that's a sign change, and then it stays negative for the 6. So there's one sign change from positive to negative. One sign change means that there's going to be one positive solution. Since there's one positive solution out of 3, that means 2 of the solutions are going to be negative. But anytime you're talking about 2 solutions, it's 2 or 0. Step 3, write down the possible rational solutions. This is where you take the factors of the constant term. In our case, our constant term is 6. So the factors are 1, 2, 3, and 6. This actually means that there are 8 possible solutions, because positive 1 or negative 1 might be a solution, positive or negative 2, positive or negative 3, positive or negative 6. So some teachers would say, check all 8 of them, or just start working on positive, negative, until you find the right one. But because of Descartes in step 2, we know that there's definitely one positive solution. There might not be any negative solutions. We might check all of these and have none of them work, which means there's imaginary solutions. But we know there's definitely one positive solution. That's where we're going to start with. Step 4 says, test rational solutions using synthetic division. When you get a remainder of 0, you found a factor. So I'm going to write in 1, 2, negative 5, negative 6. Where did those numbers come from? From the original function. So the coefficients, 1, 2, negative 5, negative 6, the coefficients of that polynomial, that's what you write in the synthetic division. We are going to start by trying positive 1. We're going to plug 1 into this synthetic division and see if it works. Our goal is to get a remainder of 0. So let's try this. Do you remember synthetic division? Drop the first number down. Multiply. 1 times 1 is 1. Add those together. Multiply. 1 times 3 is 3. Add them together. Multiply. Is that going to be 0? No. So, 1 doesn't work. So next, we need to try synthetic division again. This time, we will try 2. Two times 1 is 2. Add them. 2 times 4 is 8. Add them. 2 times 3 is 6. Oh, hey, remainder 0. Okay, we got the remainder 0. That's what we were hoping for. Now what? When you get a remainder of 0, you have found a solution. 2 is a solution to this function, which means x minus 2 is a factor. Because think about, if we do 0 equals, what's the solution here? The solution is 2. That's what's in the synthetic division. This is why we do the opposite in synthetic division. The rest of the synthetic division, that's the result of dividing. So the next set of parentheses is x squared plus 4x plus 3. So I'm going to highlight that and highlight this so you can see the connection between the result of synthetic division and how we are factoring the polynomial. Okay, do you suppose we're done factoring? No. So we have x minus 2, x squared plus 4x plus 3 is going to factor into 2 binomials. What is a number that multiplies to give you 3, 2 numbers, and add up to 4? Positive 1, positive 3. We just factored a polynomial that was previously unfactorable. I do this to you because it's fun. Okay, so step 5 said finish the factoring. So synthetic division gave us this partially factored polynomial. The x minus 2 came from the fact that 2 is one of our solutions. The x squared plus 4x plus 3 came from the result of that synthetic division. We finished factoring x squared plus 4x plus 3. Now we need to finish solving. So what are our solutions? Our solutions are positive 2, negative 1, and negative 3. Now, go back up to step 2, Descartes' rule of signs. Descartes' rule of signs said that we would have 1 positive solution and 2 negative solutions. Bam!